module 3.
Oh, I'm almost out of module 3. I got 15 more trials to do here.
All right, are there any problems in particular that are kicking your hiney? In any module you want me to look at?
You see, when I be doing them knowledge, I gotta start writing that stuff down. Cause some of them things I be forgetting, but they be
Yeah.
back in like module 1 and module 2.
That's fine, that's fine. And that's the good thing and the bad thing about those knowledge checks. You think you know it at the time, and then it creeps back up on you in a knowledge check.
Yeah, and it spooks you.
It spooks you, it's like a bad nightmare.
Yeah.
And that's the good thing and the bad thing about math is, you know, in history, you have a test on World War I, and then the test is over and you doesn't have anything to do with World War II. But in math, everything builds and it just keeps coming back up.
Keep coming back up.
And that's why Alex is going to make you a better math student. Because when you get into Module 3, it's built on Module 1 and Module 2, and you keep getting those knowledge checks. Because it's keeping you on your toes. So even though we're learning new stuff, I keep throwing back the old stuff up at you to make you stay on your toes.
I ain't gonna lie though, I learned more in college than I did in high school.
That's good.
That's, yeah, I ain't gonna lie.
I have learned more about math than
I learned more math in college
in
and high
this remedial
school.
class.
That is
I had it
awesome.
4 years of high school.
That is awesome. And that's why we chose Alex. I mean, we used to teach it old school paper and pencil, and we used to use it in my math lab. But Alex is just a wonderful learning software that makes you go back and get the old school.
I was just about to say, I was like, in college, like, you learn more than what you learned in high school.
Amen. And I used to teach public school. And I mean, when you make a 30 on a fraction test, and they say, okay, let's go on to decimals, they don't, I mean, I hate to say they don't care because they do, but everybody has to go on to decimals even though you didn't learn fractions, and you're screwed. Because you can't learn fractions unless you know the decimals.
And Alex, it make you get it. You going
Right, and Alex is going to make you get it. And even if you move on, it's going to make you go backwards. So, even though they don't call it juicy pie in high school. All right, now, I'm going to go on and make you do a couple more things. We're going to pick up where we left off and just try to get to as much as we can. Let me pull up, so I'm glad y'all are learning something. That's always nice to know that y'all are getting something out of this. Last time we talked about perimeter. Perimeter's the distance around. Perimeter has plane units. Now we're going to talk about some area. Area's the inside. So perimeter, we didn't care what the shape was. Area's the inside. And the formulas for area, we have a rectangle, we have a square, we have a parallelogram, we have a trapezoid, and we have a triangle. Now, a rectangle, the only difference between a rectangle and a square, a rectangle, the left and right are equal, the top and the bottom are equal. A square, all four sides are equal. A parallelogram is a squished rectangle. When you're doing a triangle, you have the base and you have the height. Your base is what you sit on, your height is straight up and down. When you have a trapezoid, your A and your B are the parallel sides. Those are your railroad tracks. Your height is straight up and down. When you go to the doctor, they always measure your height straight up and down. You never use the slanted lines. Just like when we're doing a parallelogram, your base is what you sit on. Your height is straight up and down. You never use the slanted lines. So, for this one, it is a triangle. So we come up here, we use the formula of a triangle. It is 1/2 times base times height. Your base is what you sit on. So my base is going to be 18. My height is the straight up and down. So my height is going to be 5. They gave you the 13 to confuse you. The 13 is never used. If your doctor measured your height that way, you would be a 7-foot tall person. So you go to your calculator, one height is a fraction, times 18 times 5, you're done. Units for area is squared. So this is gonna be square feet, or square centimeters, or square whatever. We good?
Question, where
Yes.
everybody at? You let them people go that you got it?
There are a couple people that are in module 4, so I let them go because they're ahead of us and they don't need geometry. There are a lot of people that are still in modules 1 and 2.
Oh, so they still working in the hub?
They are downstairs in the tutoring room serving time, like ISS.
Oh, I thought that you just let everybody go out.
No, I am checking their time downstairs in the tutoring room. So they're serving the same amount of time, but there's no need for them to listen to geometry when they're still worried about whole numbers and fractions. Because they sit back there and they go to sleep and they're not listening to a word I say. So they have to serve their time downstairs.
Or they don't work when they go home.
Correct.
I need to start doing that. How you let those people go home today? What they did? Got their pot to 100.
No, they like,
They-
they're in module 4, so they're.
Remember that day I went?
But she said I don't have to see you again.
Who?
You told me
Shannon.
what she did.
She has her pie at 100 and she took her scheduled assessment today and made a 95. So she is done with the course.
See,
What,
I knew it was something going on with her. I heard it.
what
Yeah.
about, the Mexican fella? He did 93, didn't he?
The who? The Mexican guy that sat next to
Yeah,
her?
he finished. He
He's
was the
finished.
First, he was the first person that finished.
Yeah, he's finished. We've had 4 people in this class finish
Already?
Yeah.
already.
Dang.
Yeah,
I
Yeah.
ain't paying that much attention to
He was the first
I know.
one that finished.
yeah.
You know,
All right, now, look at this
I
one.
need to work on that so I can get out of here.
Yeah. And even if I've had some people that finish and want to go on to the next class, Shannon that finished today, she's like a taller, skinny black girl. She finished today, but she needs Math 107. You can either say, I'm done, I don't want any more math, which y'all, motivation to be done is you get 4 extra hours on Tuesday, Thursday that you don't have to come to class.
Right.
That's motivation right there. But if you need extra math courses like 101, 102, you can actually start the next math class this semester.
Oh, okay. We can start early.
Yeah, so after you leave 033, you will it's according to your major. You either need 101, 102, and you can move on to that course this semester and get a head start.
What else do you teach?
If you need 155, 107, or 170, then you're gonna have to wait till next semester because those are not hub classes.
Ooh.
So your motivation would be, I get 4 extra hours that I don't have to come to math class. I teach everything. My classes that I usually teach every semester that are like my loves are this class. I love teaching Math 033. And I usually teach Math 107, which is a stats class. Once in a blue moon, I teach Math
Who
155.
got 101 and 102?
101, Miss Al is wonderful, Howle. She is like my sidekick, the one that looks just like me and talks just like me. She is wonderful. But when you go to register for classes, if you want to know who I like and who I don't like and who I would recommend, I'll be glad to tell you.
You say who you like and who you don't like.
Yeah. All right. Now, y'all, we want to know the area for this. I know Lindsay was working on this today. We want to know the area. In order to find the area, we have to know the shapes. So what shapes do you see here? When you look at this, what shapes do you see?
Rectangle.
Triangle.
Okay, what is your outside shape?
Triangle. So triangle.
So it's going to be a triangle and a rectangle. Now, you have to realize that it is a triangle minus a rectangle.
Right.
And I have some people say, well, why is it not a triangle plus a rectangle? If it was a triangle plus a rectangle, it would be a triangle plus a rectangle. If you add them, it's like gluing them together.
Right. So
This is a triangle minus a rectangle.
right.
So you're taking it away. So our formula sheet tells me that the formula for a triangle is 1/2 base times height, and a rectangle's length times width.
Right.
So let's go to the rectangle first. What is the length and the width of my rectangle?
2 and 4.
2 and 4. So 2 times 4 is 8. Now let's go to my triangle. This is my triangle.
Right.
What is the base of my triangle?
8,
Oh, what is
is
it, triangle?
6 plus 2.
This is what gets everybody. 6 is only from here to here.
Oh,
The base of my triangle is from here to here.
Okay.
So there's a 2 right there, which means my total base is 8.
Other side 8 too.
Now, from here to here is 4. From here to here is also 4.
So it's 8.
So the total height is going to be 8.
Yeah, that's 64.
And then what is half of 64? 32. So the triangle is 32 minus the rectangle of 8. So 32 minus 8, my answer is going to be 24. And because it's area, it's 24 yards squared. And like I said, if it was a triangle plus a rectangle, it would look like that. Does that make sense?
Because you're adding instead of taking away.
Correct. You're gluing together instead of cutting out. Now, I think Calvin was working on this one when we left.
Yes, ma'am.
What is my outside shape?
Rectangle.
So for this one, I have a rectangle and I'm taking away a triangle. So this one's going to be a rectangle minus a triangle. The formula for rectangles, length times width. The formula for triangles, 1/2 base times height. So what is the total length and the total width of my rectangle? Total length and total width of my rectangle.
8 and 6. No.
6 only goes from here to here.
9 and 8.
9 times 8. That is my total length and my total width. 6 is a partial and 5 is a partial. 9 times 8 is 72. Now, if let me get my pens. This is when we did this missing side stuff. If this is 5, do you see those two pieces have to add up to 8?
Yeah.
So if this is 5, what does this have to be?
4.
5 plus what gives me 8?
3.
3. So that piece is 3, even though they didn't tell me. If this piece is 6, what does that have to be to give me 9? 6 plus 3 gives me 9. We can't just say, oh, they look the same. The top two pieces have to add up to 8. So that has to be 3 if this is 5. So that piece is 3. If this piece is 6, this piece has to be 3 for them to add up to 9. So my triangle, if I turn my triangle cattywampus, let me take that, clone it, and turn it. So if I turn my triangle, can you see that 3 is my height and 3 is my base? So 3 is my base, 3 is my height, and if I go to my calculator, I'm going to do 3 times 3 is 9, and then half of 9 is going to be 4.5. So 72 minus the 4.5. They look a whole lot harder than they are. So the area is going to be 67.5 meters squared. We good? All right, let's go to another one. What do you see here? Rectangle minus,
Triangle.
so it's going to be length times width minus 1/2 base times height. What are the length and the width of the rectangle? 5 and 6. And the base and the height of the, and again, you may not see it, but if you turn your head cattywampus, can you see that your base is 3 and your height is 4? What's 3 times 4?
12.
And half of 12. So 30 minus 6 is 24. They're going to explain it a lot harder than that. On your formula sheet, the area of a parallelogram is base times height. What is your base? What's the base of that picture? 11, because a parallelogram is a squished rectangle. And in a rectangle, the top and the bottom are the same thing. So my base is 11. What is my height?
10.
My height is 10 because your height is always up and down. They gave you a number that you don't need to confuse you.
Yeah.
So your area is going to be 110 and area is always squared. Trapezoid. The formula for a trapezoid on your formula sheet is 1/2 times height times A plus B. Your A and your B are your parallel sides. So it doesn't matter which one I call A and B because A plus B, B plus A, they're commutative. That gives me 18. What is my height?
7.
Your height is 7. Your height is always up and down. So I go to my calculator and I'm going to do 1/2 times 7 times 18. Oh, who would it be?
It is Chance Jerry.
He is right here. He took a chance and you found him. You're fine. Thank you. So 63, and because it's area, it is meters squared. So your A and your B are your parallel sides. All right, some definitions for circle. If I tell you the number that's all the way across, that is called the diameter. If I tell you the number that's halfway across, that's called the radius. So if the diameter is 50, what is the radius going to be?
25.
25. So whatever the diameter is, the radius is going to be half of that. Now, if I give you the side that does not go through the center, that is called the chord. So in this problem, it says name the radius. The radius is the one that goes halfway across. So the radius could be called MJ or it could be called JM. It does not matter which way you name it. The diameter is either going to be LK or KL. The chord is going to be ON or NO. The chord is the one that skips the middle. Now, JM is 6. How long is KL?
12.
12. That's all they wanted you to do. And the way I keep it straight, diameter, radius. Diameter is long, radius is short. All right. Let's do a circle has a radius of 16. We want to know the circumference. I'm going to do the circumference and the area, just so that we can talk about it.
That's the one they use in the pie for.
So, it told me in the problem that it has a radius of 16. On your formula sheet, this just lets you know that the diameter is 2 radiuses, and the radius is half of the diameter. Now, area of a circle is the inside. Circumference of the circle is around the outside. The way I remember it, C for circumference reminds me of the crust, the pie, the crust around the pie. So, if I'm doing area, the formula for the area is going to be pi times r squared. Pi is 3.14. They gave us the radius, so the radius is 16. So to get the area of a circle, we would do 3.14 times 16 squared. This would be my area. So So the area of this circle is 803.84, and area always has square units. Now, I only have one area formula. Circumference was nice enough to give me two formulas. They gave me one if I knew the radius, and they gave me one if I knew the diameter. So I know the radius. So because I know the radius, I'm going to use this one. 2 times pi times r. So 2 times 3.14 times 16. So to get my circumference or the crust, 2 times 3.14 times 16. So if I want to know how much crust I have, 100.48. Circumference is like perimeter. So my units are going to be plane. Circumference is the circle, how much around. So y'all, if you were cutting grass, you would want to know the area. If you were running a lap, you would want to know the circumference. How many miles did I run around the lap? That would be circumference. All right. These are tough. I know Lindsay was working on these today. Find the perimeter. How much did I walk? If I walked all the way around, how much did I walk? That's the perimeter. So, do you see that I walked 2 flat sides and 2 curved sides? So, this was a flat side, and this was a flat side.
So the next side will be 86, and the next side will be 64.
Well, I didn't cut through. I didn't walk here. That's a 64. I didn't walk there. I walked here. So, can you tell that if I take that piece and this piece and I squish them together, can you tell that makes an egg or a circle? With a diameter of 64? You with me? So, I want to know, would I be finding the area of that circle or the circumference of that circle?
The area?
Do I want to know the inside or the outside?
Outside.
So I would be trying to find the circumference. I want to know the crust, the outside. So am I going to use the 2 pi r formula or am I going to use the pi d formula?
2 pi r.
What do I know about this circle?
The diameter is 64, so the radius is going to be 32.
So I can really use either one. I can use 2 times 3.14 times 32, or I can use 3.14 times 64. Because both of those are formulas for circumference. Because if you look at that formula, they gave us both formulas, but if you look at the formula, they both have pi in it. But look right here, what's 2 radiuses? A diameter. So they're really the same formula. But just so that I can show you, if I do 2 times 3.14 times 32, or 3.14 times 64, it's going to give you the same answer. So 200.96 represents how much it's going to take me to walk a full circle. Well, if I cut that in half, 100.48 is what it takes me to walk half a circle. So that means I can walk 100.48 over here and 100.48 over here. So if I start right here, do you see that I walked 86? And then I walked 100.48. And then I walked 86. And then I walked 100.48. That's my perimeter. So it's going to be 86 plus 86 plus 100.48 plus 100.48. That's going to be my perimeter.
School.
Yeah.
How come when you use the pi symbol on the calculator, it gives you a different answer?
Okay. I'll show you. I think I did a plus instead of a point. Plus 100.48. Very good question, Calvin. So this is going to be the perimeter of the entire thing. The perimeter is, and my units are going to be plain. Now, Calvin noticed that there is a pi button on your calculator. The pi button is located right above the to the button. So if I do second and the pi button, when you hit the pi button, it gives you all of pi, 3.141592654. So when we use 3.14, we're using a piece of pi. We're just using a slice of pi. When you use the pi button, you're using all of pi. So your answer's off because we're like using a rounded pie, a little slice of pie. They're using all of pi. So they did 2 times 3.141592654 times 32. So our answers are off because of rounding. Very good question. Now, they want me to know the perimeter, which means we're going to add up the sides. How many flat sides do we have?
2.
If I started here, I walked this, 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 and this. How many flat sides? I have 3 flat sides and
A curve.
1 curved side. C-U-R-V-E. How long are my flat sides?
One is
15.
15. And the next one is 21 inches.
How long is the third one? Because you told me there were 3.
21 inches.
So, do you see that this is 21, this is 15, and this is 21? Now, let's go for our curved side. If I come over, do you see that my curved side is half of a circle? So if I come down here and draw a circle, what's my diameter of that circle? What's the diameter of my circle?
What number? 15?
15. The diameter of my circle is 15. Because you see my rectangle, the top and the bottom are equal, the left and the right are equal. So, do I want to know the inside of that circle or the outside of that circle?
The inside.
Are we doing the area or are we doing the perimeter?
The outside.
So we're doing the circumference. So am I going to use the pi d or am I going to use the 2 pi r?
You can use both.
You can use both, but I'm going to use what I was given. Was I given the diameter or the circumference? The diameter, because the diameter is all the way across. So 3.14 times 15, because this is the diameter. So 3.14 times 15. Now, what does this answer represent? Me walking where?
Around that circle?
The whole circle. Did I walk the whole circle?
No.
How much did I walk?
Half.
So I'm going to take half of that because I only walked half the circle. So 23.55 is me walking half the circle. So 23.55 is me walking half the circle. So to get my perimeter, I walked a 21 plus a 15 plus a 21 plus a 23.55. I walked a 21 plus a 15 plus a 21 plus a 23.55. There's my answer.
Is that the same thing you did with the full court?
You put the inches square on the end of it, right?
And then it's perimeter. So what kind of unit?
Plane.
Plane. I'm loving the one we have now. Okay. Now this one we walked a 86, a half a quart, an 86 and a half a quart. Now what if I had drawn it this way? That would have been what if I had taken, hold on. What if I had drawn it this way? Not that way. That way. And it was my 21 and my 15. It would be a 21, a 15, a 21. Do you see that that's still half a circle?
Yes.
But instead of walking, I'm walking and there's a tree right there. So instead of me walking this way, I'm walking this way. So it's still the same